It's 5 after. Good afternoon, everyone. Appreciate everyone attending the Wednesday webinar series. Today, we're going to continue our automation talk around automating BigIP with Terraform. We've got Daniel Kaye and Stephen Hillier, both on the federal team, but north of the border in Canada. So they'll be presenting today and doing a little demo at the end. So without further ado, Dan, you want to take off?
Yes, thank you, Ryan. My name is Dan Kaye. My colleague just said, I work out of the city of Ottawa in Canada with my colleague Steve Hillier here. And I'm going to start this off. Make sure I got the right screen. You can see the agenda screen, I suspect.
Yeah, you're looking good.
Perfect. We're going to show you a slide of the previous topics that we have covered in these F5 Wednesdays over the course of the last few weeks. We're going to then talk about Terraform, of course, and we're going to show you a demo of deploying F5 BigIPs using Terraform. And at the end, we're going to review some of the upcoming topics that will be covered in these Wednesday series. Let me just grab my screen here. We want to keep this session as interactive as possible. This session is for you. Feel free to ask questions at any time during the session. I suspect may or may not have a chat option in your Zoom screens. There might be a Q&A option as well. Feel free to use that, or if you have your microphone, you can try to interrupt us, but I think those might be turned off. I'm not sure. But yeah, we like interactive, so feel free to pipe up if you have any questions. In our demo today, talking about Terraform, we're also going to make use of AS3, which was covered in the previous session a few weeks back. If you were attending that session, you will know what that is. If not, we'll do a brief overview of that as well. I think all of the sessions were previously recorded as well. If you are interested in reviewing or re-watching any of them, just let us know. We can make that happen for you. What is automation? We are seeing more and more organizations using automation instead of doing the manual approach, the manual configuration of their appliances and their servers and virtual machines and such. And the real reason is because it's much faster, but also because it gives consistent results. Today with Terraform, we're going to see the concept of, I think we might have covered that in the previous session as well, the infrastructure as code aspect that enables us to do these deployments and this configs very fast and with consistency. This slide gives us a high level overview of what the journey with infrastructure as code might look like. The objective here is to express the desired infrastructure state as code, as code in a text file. That in turn makes it very easy to recover or to revision the state of that infrastructure. I'm going to call out to my colleague Steve here. Steve, can you tell us a bit more how you've seen this? How have you, because I know you've actually helped a lot of customers move from manually configuring BigIPs into configuring with infrastructure as code methodologies and automation. What have you been seeing?
Thanks, Dan. Yeah, so over the last, I'd say 18 to 24 months, a large percentage of our customers have started adopting public cloud infrastructure with a lot of vigor, actually. And that's kind of accelerated over the last 6 to 8 months with COVID-19 and with everybody working from home. And so there was a real need, a pressing need to be able to build out infrastructure in the public cloud in very timely fashion, much faster than they would do with their traditional data center deployments or their private cloud setups. And that's when we started introducing our customers to the concept of infrastructure as code and automation orchestration at a more general level. And they quickly started to see the value when they were able to invest the resources to defining their infrastructure, their architecture once in text files as code, as you already said, Dan, and then to just reuse that code to deploy more replicas of that environment. So if you think about a traditional data center environment, you're going to have a lab set up, you're going to have a staging environment, and maybe even a development environment before you get into production. And typically you want to keep a consistent design with all of these different iterations of your architecture to ensure that you get a consistently reproducible result every single time. If you're testing a workflow or an application in the lab, you want the same behavior when you move to staging, and you want a similar behavior when you move to production, so that the test results that you derive from your lab testing or your staging environment testing and validation are what you actually get as a result when you move that workload into production. And as I mentioned, with COVID-19, there was a rapid adoption of public cloud in our specific customer base. And so not only did they need to get that consistency, they needed the agility and the rapid deployment. And what they experienced after making the investment and moving away from manual configuration to adopting an infrastructure as code approach is the ability to rapidly deploy these environments consistently across multiple government branches, government departments, and organizations, so that everybody is employing the same security perimeters. They're enjoying the advantages of this highly robust architecture. And from a security compliance perspective, all of these unique workloads are benefiting from being deployed into this consistent architecture over and over again, instead of getting these one-offs where you have small variances here, small variances there, and then the auditors come along and say, hey, wait a minute, that doesn't look right. They've noticed a significant drop-off in those types of occurrences after adopting the infrastructure as code approach. So they've been able to provision their infrastructure more quickly. They've been able to adopt a revision control and management system for their configuration and their infrastructure. And as a result, they're seeing fewer deviations from standard, enhanced compliance to regulatory controls, and a consistent customer experience and user experience as they start interacting with these workloads as they're brought online.
I'm going to go on the next slide here and maybe see if you can explain to us how you built the demo that we're going to see today. What are we seeing in these slides here?
Yeah, so starting down that journey of infrastructure as code typically begins with picking your orchestrator tool of choice. Now, in previous topics, we've touched on Ansible. That's another very popular toolkit. It uses an imperative or imperative approach to actually implementing your orchestration and your automation. Today, we're going to be talking about Terraform, which is a little bit different. It uses a declarative model. In fact, it's the same model that we use on our F5 BigIP products as well for automating configuration and provisioning. Typically, with your infrastructure as code journey, it starts off with actually generating the code itself, and that's often a learning experience where you pick your toolkit of choice. Personally, I like using Microsoft Visual Studio Code as my code editor of choice. It's got a pretty rich ecosystem of plugins or extensions, as they call them in the VS Code world. And these tools help accelerate the adoption of your automation orchestration framework. They help accelerate the learning curve as you're figuring out how to work with these new tools and transitioning from your legacy, manual building to figuring out how to do this all through expressive code. When you start getting into working with code, very, very shortly thereafter, you realize there's a strong need for document management or version control, revision control. And that's when you start looking at tools like GitLab. Git is probably the de facto standard for source code revision control today. Here you see a screenshot of GitHub, which is probably one of the most popular publicly available revision control systems out there. I use it heavily because it makes it easy for me to share code with customers, share code examples with customers. In fact, the screenshot you see here today is an actual live repo where I stored the code that we use for today's demo. So if anybody's interested in kicking the tires on this after the session is over, they can feel free to. We've actually got a link at the end of the slide deck that people can use to pull this example down. There's actually a number of examples that you can take a look at. But one of the advantages of the revision control is the ability for you to tag a specific, basically stamp your code implementation at any point in time. Say, okay, this is gold master, this is master revision 1, revision 2, or revision 3. And as you develop new modifications or new iterations of your architecture, you can always revert back to a previous version if you'd like, for either if you want to roll back some changes you don't like them, or if a particular workload requires a specific revision of your architecture, then you implement it in code. There are typically in large organizations, there are a number of other steps that come along with your infrastructure as code adoption. That includes a code review process where the implementation is reviewed by peers, a part of a code DevOps team, before it gets approved and stamped and tagged. Then there's an integration and testing environment. Often that's where you see the dev/staging environments where revisions to your infrastructure are validated through a testing regimen. And then finally, you deploy that implementation into production environment. Now, sometimes that's instantiating a new environment. Sometimes it's applying revisions to an existing environment. But in either case, it's at a high level. Now, this is kind of like the 10,000-foot view, but this is generally how we've seen our customers adopt infrastructure as code over the last couple of years. This is just a screenshot I took of a test run deploying the demo for today. As Dan mentioned, we're talking about Terraform today, so we are seeing both Terraform on the command line. One of the things I really like about Visual Studio Code is that it has the toolkit to integrate your command line operations alongside your actual text editor where you're writing and revising the code implementation itself. It also has pretty tight integrations to your revision control system. So when I've finished making my modifications, it's trivial for me to simply click a few links and check in that new code into GitHub for safekeeping. So yeah, this is just a general overview of what that process looks like. Back to you, Dan.
Thanks, Steve. And to reiterate, what I like with Terraform, I didn't know, what I like with Visual Studio Code, which I started using when I started learning Terraform, is the language interpreters that highlight with the nice colors, but also the syntax correction. They become an enabler for me to be much more efficient when I'm tweaking or troubleshooting or creating code. A very powerful tool. If you don't know it, go check it out. VS Code. F5 has created some automation tools that are free, that you have access to as an F5 customer for your BigIPs. They allow automating of a number of steps that need to happen when you want to deploy a BigIP, especially in virtual and cloud environments. And these tools here are specifically designed to do it in a declarative manner. The concept is we define what we want the result to be, and the tool makes it happen. It does everything it needs to do in the proper order and does it. These, if you have not seen them before, as I mentioned, the AS3 was covered in a previous session. That allows the configuration of the software on the F5 appliances to occur in a very declarative manner. We have the Declarative Onboarding Toolkit, which is an API that allows us to perform the initial config settings on the appliance after it's booted up. For example, network IPs, licensing on the box, configuring the NTP and DNS servers, all of the stuff you usually do the first time you boot up the appliance. That's this declarative onboarding. Steve, can I get you to talk about a bit the telemetry streaming?
Yeah, so as Dan mentioned, we offer an array of declarative REST APIs for automating the process of deploying and applying initial configuration to F5 appliances, both private cloud if you're using a hybrid cloud model, or in the public cloud, which is quickly becoming the go-to standard. Telemetry streaming is one of those packages. Provides a declarative REST API for you to configure the off-box streaming of log data, performance data for centralized collection and storing and analytics. Now, As a part of the demo that we put together for today, we're leveraging all three of those REST APIs that we just talked about. Telemetry streaming, it provides integration with a vast array of tools, both cloud native tools as well as private data center tools. We even have customers leveraging telemetry streaming on physical BigIP hardware, just to simplify, automate, and orchestrate the configuration of a centralized collection of logs and performance statistics from the virtual servers and the applications that they're handling on their BigIP devices. In the on-prem world, it supports Elk Stack along with a whole bunch of others. And in today's demonstration, we're actually using the Azure Cloud Native service called the Log and Analytics Workspace as the target for streaming our log data and our performance telemetry. So again, it's just another toolkit that we provide to our customers to kind of ease the process of integrating deployment of BigIPs into your DevOps workflow through an automated approach.
Awesome, thanks, Steve. All right, let's get to it. What is Terraform? As Steve indicated, last week we covered Ansible, how to configure the software on your BigIPs using Ansible. We typically see customers using Ansible after the base infrastructure has been deployed, after the BigIP has been booted up and is reachable. Today, we'll show you how Terraform makes it easy to deploy and provision these BigIPs, the BigIP instances, the BigIP virtual machines in the first place. Terraform is purpose-built for provisioning infrastructure components just like the BigIP and much more. You'll see in the demo, the Terraform code Steve has also will deploy and configure a simple web server with a fully working website. And now we'll start looking at the demo. So Steve will show you how he can apply that code, that infrastructure code using Terraform. As I indicated, he'll spin up a fully configure virtual machines and a simple website in Azure today. After the bootstrap process and after the device onboarding steps have been successfully completed, Terraform's, the code that Steve created, will then use AS3 and telemetry streaming endpoints to configure the actual software on the BigIPs. So using Terraform in combination with these tools that we have available on the F5 BigIPs, it allows us to perform the entire deployment process from spinning up the HA pair of BigIPs in Azure today, configuring the network interfaces, configuring the HA, the clustering between the BigIPs, and even spinning up that web server. All that is being done thanks to Terraform. That's what we're going to show you today. The configuration on the F5 will also include SSL offload and some basic security policies for that website that's going to be spun up. This demo, Steve mentioned the Git repo is going to be, it is available for you to go look at, and you can look at the code on your own. This is the representation of the desired architecture that the code actually builds out. And I'm going to ask Steve, maybe if you can start sharing your screen and show us the actual code and what it looks like on your computer with VS Code.
Absolutely. Just give me a second here. Switch screens. Let me know if you can see that.
I see that. Perfect.
Fantastic. So, as Dan mentioned, last week we covered Ansible, which follows an imperative approach to automation and orchestration. In the Ansible world, they use playbooks, and essentially you explicitly define the steps that you want to perform and the order in which you want to perform them as a part of your automation and orchestration workflow. Terraform takes a bit of a different approach. It uses a declarative model. So, and I believe Dan touched on this earlier in the slide deck. So essentially with Terraform, you define the state of your infrastructure that you want it to, that you want the tool to actually go ahead and build for you. And then Terraform the Terraform providers actually go out and figure out the order of operations that needs to be followed in order to achieve that desired state in the Terraform parlance. It comes up with an execution plan. And once it figures out that plan, it then goes and follows that execution plan to go and build the infrastructure that you've declared. So essentially, you declare or define the state that you want the tool to give you, and then it goes out and figures out how to actually make that happen, and then subsequently goes out and actually does the work. And the F5 REST APIs that we're going to be employing today use a similar model. So instead of following the imperative approach where you have a list of steps that you follow in a very specific order to configure your BigIP appliances for application delivery or application security, you basically declare the state of configuration state that you want your BigIP instances to be in. And then those REST APIs are responsible for consuming that declaration and figuring out all of the individual steps that they need to follow and the order of operations that they need to follow in order to achieve that desired state that you declared. So just trying to compare and contrast the two. I'm not saying, there's no one is better than the other. That's absolutely not an argument I would even try to make. In fact, what I've observed with our customer base is that they employ the combination of those two tools. Often I see Terraform being used for the initial deployment of your infrastructure. So you declare the infrastructure's initial state for it to be built in. And then in subsequent day two operations, when they want to get into making changes or adding to an existing set of infrastructure, sometimes they'll switch to using Ansible as the automation tool of choice. It's been my experience that Ansible is very, very well suited to configuration management, and Terraform is very well suited to infrastructure management. So it would not be uncommon to see the combination of both of those toolkits on some of these DevOps teams that we work with across our customer base. So here in the window, what you see is my Visual Studio Code instance running here. Over on the left, I've got a number of different folders. The folder I'm working in today is HAVLB. Again, that corresponds to the GitHub repo that we'll share with you at the end of the presentation. And it's simply a flat folder with a number of different files in there. And the way Terraform works, there are two sets of files that it's primarily interested in, the .tf files and the .tf-vars files. When you invoke Terraform, it basically reads in all of those types of files in the current directory. It won't go searching into subdirectories or anything like that. It concatenates all of that information in memory, and to get a holistic view of the declared infrastructure state that you'd like to build. And then it comes up with the execution plan, as I was saying earlier. And then once it has that plan, if you tell it to do so, it will go out and execute that plan to build that infrastructure for you. If any of the audience is familiar or has any type of background with shell scripting type automation or any type of programming, the concept of a variable will be very familiar to you. And a lot of those constructs and concepts are very much portable into the Terraform world. Here you see an example of some of the variables that I've declared for use within this automation example. Some of them are passed in, some of them are defined with default values. You can see I've defined a couple of IP subnets that I'd like to be leveraged and some static IP addresses that I'd like to assign to specific devices within that architecture. Now, because we're doing a live demo here, there is a time constraint. And so what I'm going to do here is I'm going to kick off the actual build process, which is actually pretty simple to do. And it's just a Terraform apply, and I'm passing in the auto approve flag so I don't get the interactive prompt saying, hey, do you actually want to execute this plan that I've come up with? I'm just telling you, yes, go ahead. Sacrifice to the demo gods as always, and kick this one off. Now, while this is running in the background, I'm actually going to take a moment to explain, just to give you a quick overview of what I've declared here.
And Steve, so while you're showing that, there's a question that came in the Q&A is, will we get to see all the cloud artifacts like the VNets, et cetera, that Terraform will be configuring beyond the BigIP?
Absolutely. So if I have my Azure portal screen up here, you can see it's empty. And now that I refresh my screen, it's created this demo resource group, which is a top layer construct within the Azure world where all of the individual infrastructure artifacts that I'm creating will be built. And if I drill down into that resource group, you'll see there's a bunch of new objects being created. If I refresh this view, give it a few seconds here, and you'll start to see additional objects start populating in this list. So it's actually building live as we speak here. Like I said, sacrifice to the demo gods, this is a live one. If I refresh my view, you'll see there's additional objects being created as we go along here. I'll take you through the entire architecture and correlate that back to these objects, but we'll refer back to that diagram that you were showing earlier, Dan. So this is under my F5 demo subscription with Azure. So I'm actually building this live right now. And now I'll take you through the individual objects that it's building. So first of all, in the main.tf file, I should take a moment to explain. As I said earlier, Terraform concatenates all of the contents of all of these .tf files into a single large declaration. How you break that up is a matter of preference. And the reason I break them up into separate files is for ease of management. If I want to go back and make changes to the networking, I don't need to scroll through 100, 200 lines of code to find where I define my network elements. I simply go to the network.tf file because I know that's where I declared all my network elements. You can see I've got a single Azure VNet or virtual network declared here. And within that virtual network, I've declared a couple of subnets, an out-of-band management subnet, an external subnet, and an internal subnet. Now, in order for this demo to be useful, I mean, it's great to be able to deploy a BigIP, but for anybody who's worked with BigIP in the past, you know that it's an application delivery controller. It's a security appliance designed to make applications highly available and highly secure. And so in order to make this demo useful, we wanted to have an actual web application workload just to have something to show when the BigIPs are deployed. Otherwise, there's not a whole lot to see other than the management screen. So over in the app server Terraform file, that's exactly what I declare. I'm going to create a very simple Ubuntu virtual machine, and that virtual machine is going to be running a Docker container, and that Docker container is going to be running a training web app that we use for web application security. In addition to the application server, we're going to be deploying, as Dan mentioned, a highly available pair of BigIPs, so a cluster of BigIPs. And I define those various elements that are, and all the dependencies that are required to go create that here in the BigIP.tf file. Again, just organizing it for whatever is easiest for me. And I know some people like to break them out into very granular little discrete pieces of code, and they have like maybe a dozen, 2 dozen files in order to achieve that. I kind of like the happy medium where I break it up a bit, but not too much. That way I don't have to scroll too much on my file browser over here on the left. But as you can see, my virtual machine instances are basically Azure Linux virtual machine types. I give them an OS disk, I give them a first-time boot script, and I reference a marketplace offering in terms of the initial image that's going to be deployed with these virtual machines. Now, in the diagram, you may have noticed that it's a pair of BigIPs, and there's actually an Azure load balancer sitting in front of them. That's one of 2 different high availability models that we support when we're deploying into the Azure public cloud. The reason I picked this one, quite simply, is it's the most popular with my customer base. Working with the federal government up here in Canada, they're only allowed to deploy virtual workloads into the Canadian Azure regions, and they've observed much faster failover times leveraging this high availability model when deploying to the Canadian regions. Now, I'm not sure if that has anything to do with the cold weather up here, but that is the preference that we've observed with our customer base, and so I simply elected to go with that as the example for today. But there is another example that we'll provide in the GitHub link that we'll show at the end of the demo that illustrates the other high availability model that we support in Azure Public Cloud, and that's via the API. So essentially, there's a piece of software on the BigIPs that talks to the SDN control plane. It's a software-defined networking control plane, and manipulates the configuration of the network to steer traffic to the active device in the cluster. And then finally, we've talked about it earlier with the automation toolchain. So the automation toolchain is what we're using to apply an initial configuration state to those BigIP virtual machine instances once they boot. And it's a 3-step process. The first process is using the Declarative Onboarding APIs, and that's where we apply the initial base appliance configuration. This is the actual JSON declaration template that we're using for that. So we apply some DNS servers, some NTP servers. We do some network configuration. So there's some self IPs and some VLANs in there. We also define our, we also declare that we want these devices to participate in a high availability cluster. So even the clustering is declared as a part of the initial device configuration state. And if we look down here in the terminal window, which is running in the lower pane of my Windows Studio Code window here, it's actually running the declarative onboarding step right now. So all the syntax, all the formatting is kind of collapsed here in this view. But that JSON declaration that I was just showing you is actually what you see here being sent to the BigIP saying, hey, this is the state I want you to, this is the configuration state I want to apply to this device. Please go ahead and do that. And then it's the responsibility of the declarative onboarding API to consume this information, parse it all out, figure out, okay, here's all the things I need to do to configure myself according to the state that's been requested. Here's the order of operations I'm going to have to follow to achieve that state. Now let me go and do that for you. And when it's done, we're actually doing an asynchronous callback to check when it's done. It'll let us know. And that usually takes a couple of minutes. Now, once the declarative onboarding process is complete, it'll move on to configuring the application delivery software state. And that's what we define in this AS3 JSON file that you see right here. So that process uses what we call our AS3 REST API. It's another declarative API where, again, you declare the state that you want it to configure itself for, and it goes out and does that for you. This is a simple example that we're using for today's demonstration. It's a simple web application. We've got a single virtual server. We've got a pool. And if you take a look at the members, the pool members list here, you'll notice that I'm not calling out individual members specifically. And instead, I'm using a feature of the BigIP called service discovery. So instead of actually explicitly saying, hey, this is my backend web application server, I'm saying, hey, any application server that has a application tag value of app1, that's automatically that's the implicit app ID for this application. So go discover that virtual machine's IP address and then add it to the pool. And we'll show you the result of that in a moment. And then finally, we have the telemetry streaming declaration. You see, it's really, really simple. I'm sending it to the Azure Log and Analytics workspace, which I declared in my main.tf file. And that's where the BigIP will send all of its system telemetry and any log data that I want to generate as a process, as a function of processing application traffic. Now, if you look down here in the terminal window, you see we've got a series of green outputs. Green is always good. And so that means that Terraform is done building out everything that we've asked it to build. And as a convenience function, I've told Terraform to output a bunch of information about the infrastructure that it's built when it's finished doing its job. And you can see there's a number of IP addresses here that I can use to gain access to my infrastructure. The top one here is the application IP address. So I'm just going to go grab that and throw that up in my browser here. Actually, while I'm here, I should note that the execution time for this was 7 minutes and 24 seconds. So in 7.5 minutes, we went out and built an entire infrastructure, a set of networks, IP networks. We built out a web application server. We built out a highly available set of big IPs. We applied configuration to those devices. We set up security groups and security rules. We set up traffic steering mechanisms, provision public IP addresses, and map those IP addresses to the workload. So if you were going to just thinking about how long it would take you to click through the Azure portal and to build all that stuff manually, it's going to take you more than 7.5 minutes. It might even take you several hours, depending on how responsive the portal is and how many typos that sneak into the forms that you fill out as you deploy all the individual components. And as you can see, if I jump back to the Azure portal here, it's not a small list of components just to build this simple demo. If I sort by type, you'll see there's 3 virtual machines here, the 2 F5s plus the backend web server, all the NICs associated with those virtual machines, along with some public IP addresses, OS disks, the Azure load balancer instance that I talked about, the log and analytics workspace that I talked about. All of that's been built out here while we've been chatting over the last 7.5 minutes. So let's just go test this to make sure everything came up properly. And this is why we sacrificed to the demo bots. I am using a self-signed certificate that was embedded in the declaration. if I follow that link, you'll see I've got my application up here working just fine. It's the OWASP Juice Shot Training app. This is one of the tools we use to train our new SEs on web application security. And this is a fully functioning test training application. You can click around and interact with this, and everything works the way you would expect it to if you deploy this in your own environment. So this is a fully functional demo. So if anybody wants to kick the tires on this, like I said, feel free to pull it down from GitHub. There's nothing especially unique about this. Again, it's a training tool to help people get more familiar with this model of this type of deployment model where you're not doing it manually, you're not doing it imperatively, you're following the declarative model. So that's just going to do a quick time check here. We did want to leave a bit of time for Q&A and see where at.
So there was, speaking of questions, another question came in and I answered it on the Q&A panel, which was related to the Terraform CLI itself. Can it be run from Linux, Windows? And I answered it as yes, it runs everywhere. I explained that you're, I believe, running it on your Windows machine. I run it on my Mac. It runs on Linux. And it's very lightweight because it's a single executable file. Very not a lot of dependencies on the OS.
Absolutely. So in this environment that you see, I'm actually using Windows Subsystem for Linux, which you can kind of see from the terminal drop-down options dialog here. So I've actually got the Linux binary installed inside of WSL, which is running on top of Windows. Talk about kludge. But I've been a Linux guy for 20 plus years. Linux is kind of my most comfortable working environment, even though Windows is the corporate standard and all that good stuff. WSL was a boon for me, let's just put it that way. So my personal preference is to run the Linux binary inside of the Windows subsystem for Linux. However, all of my customers have standardized, I'd say about 95% of my customers have standardized on using Windows development workstations as their default de facto platform. So when I'm working with my customers on some of their projects, I completely switch gears and now I'm working in PowerShell and I'm calling Terraform on a Windows platform. The behavior is identical, and I find it very, very easy, virtually seamless for me to switch between those operating environments. And I know you, Dan, you kind of default to working on a Mac. And so the experience for you is identical to the experience for me, whether it's working on Linux or Windows or Mac. They support all three. I think I included a link to the Terraform downloads page in the resources slide that we're going to throw up here in a minute. And
yeah,
it has downloads for all three of the major operating systems.
Yeah, you have. Thanks, Steve. And back to the question on the cloud artifacts, in this case in Azure, you showed us how we have all the components there, the load balancer, the BigIP, the virtual machines. Does the same exist for the actual BigIP GUI if I wanted to go into the GUI? Can you show us that?
Absolutely. So I believe I outputted the management IP addresses for the BigIP. Now, normally, this is more of a convenience factor for the sake of demonstration purposes. You don't necessarily have to map public IP addresses to your BigIP instances, but it makes the demo very, very easy. So if I just pull up the management IP address and I can log in here. Super simple password, of course. Oops, and I typed it. You can actually see this device it's configured as an active standby cluster. You'll see you've got the active and config sync is in sync, and I can browse around the GUI and go look for those application configs that I declared earlier. So we use AS3, and AS3 isolates every unique application in its own configuration partition. If you're familiar with configuring a BigIP either manually or through your own orchestration platform, partitions are probably very familiar to you. And you can see here we've got a pair of virtual servers. We've got our port 80 redirect and our SSL-enabled virtual server that's handling the traffic. It's a very standard configuration. We've got a SSL profile for terminating SSL inbound from the client browsers. And I mentioned earlier that we included the SSL certificate for this. So if I pull this up here, if I go to certificate management, you'll actually see the web certificate was included in the declaration. Oops, let it expire, so I'm going to have to review that soon. But if I jump back to my VS Code window and pull up the AS3 declaration, you'll see that the actual certificate, you can actually embed that directly into your application declaration. So all of the individual components and dependencies of delivering that application can be embedded directly in your AS3 declaration. So you don't have any external artifacts or dependencies that you need to manually throw in there after the fact. It all goes in as part of the automation pipeline.
Very cool stuff.
And the other thing I was going to show you, I mentioned it earlier, so I want to be true to my word, was the service discovery. So in our declaration, we didn't have any pool members explicitly defined. We mentioned that we were going to use a service discovery component. So if you jump into the web application pool, you'll see there's a member. It's got this pretty funky name going on, and this is actually the name of the Azure object itself. And it's got a static IP address. And obviously it works because we were able to pull up the application itself just fine. And the way that works, if I jump back to VS Code, for example, and go back to where we define the network interface for that application server, I put in an application tag. And that is how service discovery works. It'll go out and look for NICs that have this specific tag. The tag is application and the value is app1. You'll see that maps directly to the tag key and tag value parameters passed into the service discovery configs in the AS3 declaration. And that's how the BigIP is able to actually reach out and discover any of the application servers that should be members of this pool for this specific application workload. And what that means is that if I were to spin up a second application server instance, I have to do zero touch to the BigIP. I simply follow the same declaration model, basically create a copy of this app server.tf file, change all these 01s to 02s, make sure that this tag doesn't change at all. And the BigIP will pick up will automatically discover this new web application server instance and automatically add it to the pool. And it's doing that polling on, I believe it's a 5 to 10 second interval. So by the time the virtual machine boots, it's already been brought into the pool. And then of course the service health check will bring it into service once that web application, that Docker container is online and responding to requests.
And you mentioned, well, we saw the diagram. Actually, do you mind if I take over? I want to ask you about, or actually you have it up there too, right? If you want to have a more complex environment like we have seen for some of our customers.
Yeah, that's fair. That's fair. So as I mentioned earlier, that we, due to time constraints, we put together a simplified demo. Obviously, for anybody who's being introduced to this model of infrastructure as code for the first time, throwing you a massive complex example is not exactly the friendliest way to introduce you to the concept. So for the purposes of this demonstration, what we're showing you is a simple example where we've got a pair of API BigIPs and a single backend application server. But we thought there might be some value in showing you what's possible. And this is actually based on a real project that we completed with one of our customers not that long ago, as a matter of fact. It's a simplified diagram. We've removed some of the sensitive information from our customer environment, but basically they had a need to deploy a shared security perimeter using multiple security appliances from different vendors, you know, that whole defense in-depth approach. And they wanted multiple unique application workloads to be able to take advantage of that security perimeter. And the resulting architecture could be represented with a diagram like this. So on the top here, you see you've got this rather large, complex security perimeter. That's managed by the security team. And then in behind it, you've got unique resource groups in the world of Azure where individual application workloads are deployed. And so each of these application workloads is able to take advantage and leverage this shared security perimeter model that our customer was employing. Now they needed the ability to deploy this across multiple regions. In fact, they're deploying across multiple cloud providers. And by leveraging this infrastructure as a code approach, they build that infrastructure and declare that infrastructure once, express it through code, and they can implement as many replicas, as many copies of this as they want. As with any cloud provider, there are scalability limits. You're never going to exceed the cloud service provider imposed limits on throughput and things like that. So when they hit the saturation limit of what the security perimeter can support in terms of concurrent workloads, they can instantiate a second copy of it. And they know, because they've implemented it as code, that they will get an exact duplicate when they spin that second copy. And then the process of auditing and validating that environment to go live in production is much more agile, much more quickly achieved because they're getting exact copies. And again, that comes down to that consistent reproducibility of that consistent implementation that they get by leveraging the infrastructure as code model. Not to mention that they can roll this out in a matter of 45 minutes to build this everything you see in this diagram here can be built in less than an hour. And if you count up all the individual virtual machines and other components that are represented in this diagram, and then imagine rolling that by hand, you're looking at days, if not weeks. So the advantages are huge.
And then related to the advantages, Steve, nice questions just came in for you on the Q&A. Can you show how easy it is to destroy the deployment with Terraform?
Oh, that's even easier. If I jump back
Put you on the spot.
If I jump back to my VS Code window here, I don't know if I have a command here. The timer on it to show you how long it takes. Terraform destroy. And again, I'm going to pass in the proof flag, so I don't get the interactive prompt that says yes, no. It's literally that simple. When you want to build it, it's a Terraform apply, and when you want to destroy it, it's Terraform destroy. And it'll go off and start tearing down all that infrastructure I built out. And this is one of those handy little things when you want to spin up a one-off for testing purposes, and whether it's a lab environment or otherwise. It's easy to build, it's easy to tear down, and because you can capture and apply an initial configuration state to your infrastructure, when it builds, it's not build and then go in and manually configure after the fact. It's entirely usable as soon as it's done building. So based on previous tests, this will probably take 4 to 5 minutes to tear down. So a little faster than it was to do the initial configuration, but again, very, very, very quick, very, very clean.
Very cool stuff. And maybe you can show us the resource page, because I think we did provide links to all of these GitHub repos and information documents, right?
Absolutely. So if you jump back to our slide deck here, and we can share these out. So there's a number of different resources we thought would be helpful to include. So first of all, there's a link to the GitHub repo where I store the actual source code that we executed in our demo today. So if anybody's curious to kick the tires just to see what that example looks like, there's a number of other examples there for Azure, as well as other examples for AWS and GCP. So the other two major cloud providers that we've been working with our customer base. I also thought it would be helpful to include a link to F5 Dev Central's GitHub repo. There are literally dozens of examples of leveraging Terraform in different formats and different ways to implement that infrastructure as code approach to managing your big IPs. There's a quick link here to the Visual Studio Code homepage in case people aren't familiar with it and want to get a look at it. I also thought it would be helpful to include the link to the Terraform downloads page. If you've never played with it before and you want to kick the tires on it for the first time, there's a quick link to get you there, as well as a link to the documentation on the Azure provider, which is what we're using today to build out in Azure. Terraform uses a different provider for each different cloud service provider that you might want to work with. So there's one for AWS, there's one for GCP, and one for Azure that we use today. There's also some docs to our automation tool chain if you're interested in learning a little bit more about how you can leverage that in your automation workflows, as well as a link to a Dev Central article that I really, really like that's using a newer product offering from Hashicorp called Terraform Cloud. So it's Terraform, but it's Terraform running in Hashicorp's public cloud managed service offering. It's an article that explains how you can leverage that model to go about deploying big IPs. It's very similar to what we did today, but you're leveraging Terraform Cloud as opposed to Terraform on your local place.
All right, doing a time check here, 1:53. Maybe open it up for the audience. Another chance for you. If you have questions, now's the time. And maybe Ryan or Lyle, do you guys want to talk about the next topics? And unless we have more questions coming in.
If we don't have any more questions, I'm happy to kind of talk, and maybe we'll get a couple more in. So if you want to forward to the next topic slide and survey, Dan.
Okay, hang on a sec.
And I'll just talk a little bit about that. So the next topics are, we've got a couple of the previous topics in here, but some of the next topics are, we're going to do APM automation next week. And then following that, we're going to do a kind of a discussion and, talk about the different ways to move your virtual editions on-prem to a cloud and kind of what some of those strategies would be and kind of show a demo of that. So that should be pretty interesting. And then you should be seeing some invites here pretty soon for the next series, which is going to focus on, we're going to have a kind of an outlier on Splunk, and then we're going to go into a 5-week series on Nginx and what Nginx can do for you in terms of OpenShift, in terms of application security, WAF, API management, et cetera. And then we're going to finish that series up with a lab that we're going to offer up to everyone. So if you get the invites, please try to register if you're really interested in that lab. We're going to limit that lab to a certain amount of users to make sure it's that we can survive it ourselves. But be on the lookout for those. Please fill out the survey too at the end. We really appreciate any feedback. It's completely anonymous. It helps us make sure that we're getting the right topics for you guys and that they're topics that you are interested in. Matter of fact, the APM automation it's next week is something that someone had submitted earlier. So we took that to heart and made that into a webinar. So if you've got some ideas for topics, please submit them there. It's completely anonymous and we appreciate the feedback.
And Ryan, just a question came in. Are we able to send the video recording and slides out to emails that were of the registered participants here?
Yes. Sorry that I know I've promised that for a couple of weeks. We've had some logistical problems on our end of how we wanted to share those out in a good way. So those are being uploaded as we speak, and it'll be on YouTube, a YouTube playlist. Those will be in the next set of slides, and I'll send it out. If you want to post in chat, there's somebody, there's a couple people that posted in chat a couple weeks ago that wanted them. I'm sending the playlist link out to those people. If you guys are interested in it now, go ahead and post it to chat and I'll get your email address and I'll send it out to you directly. Otherwise, next week we'll have it in the slide deck and we'll post it out.
Awesome. Thanks, Ryan.
Any other questions? Well, everyone, we're just about at the top of the hour. Dan and Steve, great job. We really appreciate you presenting on this. I think this is a pretty interesting topic, and we appreciate the interactivity. Looking forward to seeing you all next week. Once again, it's on APM automation, and thanks again for tuning in. Take care.
Thank you.
Thanks, everybody. Bye.